It's either going or bending.
Mm-hmm.
One of those.
Damn, I really wish I replaced that part. Well, that pin just went flying somewhere. From what I saw, new heads are 500 each.
There we go. Now the bearings.
Yep. Welcome back to the channel, guys. It is episode 4 in the bus restoration series. We are at a point where the engine is fully disassembled. I ordered a ton of parts for this thing. Most of the parts have arrived and the rest will be here by tomorrow. So in this video, I want to capture as much of the necessary preparation work that I'll be doing before reassembly of the engine. There's still a ton of work that needs to be done on the crankshaft itself and the crankcase. Previously, I had wanted to reuse the bearings that were on the crank, but while thinking I have to clean this crank as much as I possibly can, those bearings have to come off anyway. The full kit for those bearings cost around $80. I don't want crank bearings to be something that I look back on when I have this thing all back together and say, damn, I really wish I replaced that part, because it'll just always be something that would bug me. Or if I heard maybe something that was wrong with the engine, I would think, oh, it's got to be the crank bearings immediately. So I wasn't going to let $80 deter me away from doing a proper rebuild on this, so I ended up getting the bearing set as well as dowel pins. I was working with my fiance's father yesterday. I'll play a couple clips from that shortly. We worked to remove the 2 gears that were sitting here on the crank, as well as this little spacer right here. And we had a bit of a fail. We failed to see the C-clamp that was retaining the 2 gears and the spacer, so I'll play that video for you right now and show you how it went.
It's either going or bending.
Mm-hmm.
And now one of those.
I'm not seeing movement there.
So what's bending?
There goes the tool. At the
tool
bottom
tool,
here,
yeah.
the threads.
Okay.
Eventually, we saw the C-clip, and it was a little bit more difficult than conventionally removing the C-clip from this groove here, because we had actually pulled the gears forward and it was pressing this C-clip toward the camera here, and it made it even more difficult because we were battling the friction of the gear pushing on the C-clip. So kind of difficult to show you. Probably should have monologued over it yesterday, but you live and learn. Nice.
Okay.
No need to buy a $100 tool.
Yeah. No scratches, no scratches. Okay.
And we got it off, so I may be replacing that C-clip as well, just as a precautionary thing. So I put my list together of what I'm calling an engine pre-assembly checklist. This includes things like final cleaning of all of these surfaces. I really want to get those bolt or nut surfaces clean so they seal properly. So I want to rethread any male and female threads that I can do on the crankcases itself. So another thing I want to do is remove these connecting rods from the crankcase, swap out the bearings with brand new ones. At that point, the crankshaft will be bare, and I want to do a deep cleaning on it. And I was actually doing some research, and I watched someone resurface the crank journals using sandpaper. So I want to give that a try too, and then eventually some polish. Another item I want to test is the valve guides. I've purchased 8 new valves, 4 exhaust and 4 intake, as well as this Permatex aviation sealant that leaked in this bag and is now sealed. So with these new valves, I want to, at some point, insert them into the existing guides and just check their play. Obviously, they were seized either on the valve stem here or in the guide itself at some point. And this doesn't necessarily have to be before I start reassembly of the entire engine. This has to be before I install the cylinder head. So I've got a little bit of time there, but it is something I've got on the list just in case. Another item that left some viewers hanging was the review of this Amazon valve spring compressor tool. And that is not a professional tool. Because mine were seized, it became incredibly difficult to push down on it. I ended up getting them all out, but it is not an easy tool, especially if you got some stiff springs or seized valve guides. And as you can see, well, maybe you can't see, this tool actually spread out and doesn't even fit into the case as it once did. If I open the case, you'll also see that this size, which I was initially using, I think, to go to the bottom of the valve, just twisted on me. And it's really just not durable metal. I would not suggest using a tool like this if you've got some seriously stuck or stubborn valves like I did. So I'll probably need to go get something else for reassembly. So as I'm waiting here for all my orders to come in, I'm going to try to take care of the items on the list I just rattled off that don't require me to have new parts here for. So I'm going to start with pulling my tap set out and cleaning off all the threads that I can get access to. Okay, so this hole right here in the front of the crankcase that goes to the transmission housing is the exact reason I'm glad I'm tapping into as many of these holes in the case as I can. Because look at the quantity of gunk that was just in there. And yeah, there are some metal shavings, but on this side in particular, it actually threads all the way through the case. So this hole in the case and the bolt that was in there were exposed to the elements and anything that was dripping down the case and whatever. This feels much better than it did before when I was trying to put the engine mount onto the case. Yeah, that's nice. Okay guys, so I've got the crankcase separated again, and I did that because it's inevitably got to happen. As I was rethreading this right here, I looked to my left and I saw this seam that initially I thought was a crack in the case, and it had me stop everything I was doing and put my face in it. I believe that is just a casting where two pieces meet up. It happens to be a little higher on this side than it is on this side, but you know, it doesn't, the crack doesn't continue through here, so I was a little hesitant at first. I thought the worst, but after a closer inspection, I believe it's just a casting defect. So if anyone has seen a manufacturing defect like that before, or maybe that's just how they all are, please let me know in the comments, because I would hate to put this thing back together and find out that it actually is a point of structural weakness. So let me know. I'm at a point now where I pretty much got all of the threads retapped. I think I can check that off the list for now. So the next thing I want to do as part of this pre-assembly checklist is inspect these hydraulic lifters. There's 8 of them. We tested 1 through 8 just by pushing down with, I think, the back end of a screwdriver onto the workbench over there. Man, that's messy. I gotta clean that up. Some of them gave no resistance. They went down all the way, and some of them gave very, very firm resistance. And there was so much corrosion. Okay, so I've never disassembled one of these lifters before, but I'm gonna give it a try. I believe you start with removing this retainer spring here at the top, and to do that I'm just using a little pick. Well, that pin just went flying somewhere. The valve released. Oh yeah, there's a bunch of sludge in these. Definitely worth cleaning, if not replacing. Look at the inside of there. Would not want to put these back as is. Now it's moving. So that's it. The rest is just this case. This sits in there and when properly lubricated moves up and down. And I believe this piece comes off. Yep. And that holds in the ball here, which acts as the valve to let in oil, thus becoming a hydraulic lifter. A cleaning like this will need to be done to all 8 of these, as well as bled. I'm debating whether I just want to order new ones at this point. Okay, I believe that is a fully assembled and not primed lifter. Seems like very little movement to me. I don't know. If they clean up well, I'll probably reuse them just because of the cost of new ones, and I really don't think these are in bad condition. I think they just need to be cleaned. So let me give that a try. Okay, so I just got done with all 8 of these hydraulic lifters. Wasn't too bad, it was pretty tedious. I'm hoping I'm able to clean up the surface on the bottom enough. Some of the lifters are just not perfectly clear, so I'm thinking I'm just gonna use them. I don't know, I'll have to do some research, but I'm glad I was able to at least clean them. Got a delivery. I received main bearings, rod bearings, and crank bearings are still in the house, as well as these little dowels. Technically, I can begin removing the connecting rods from the crankshaft here. What I want to do is sand these journals as well as the connecting rod journals, polish them up, make it really nice, and then reassemble with the new connecting rod bearings and put the gear back on with the bearing here and this one here. A lot of people will thread something in the back here and leave it floating here, so it's much easier to work on, so I'll just have to deal with it on the bench. My cylinder heads still need cleaning, and I'm probably going to do a good deep cleaning before they get installed, which we're quite a ways away from anyway. I actually just scheduled a knee surgery this week. That'll happen in the beginning of February, and will put me out of commission on this project for quite a few weeks. Anyway, back to the cylinder heads. This was actually the first time that I'm taking a look at them since we did the, I would say, like 60% cleaning, and I am concerned. I know that these are prone to cracking at the exhaust, and I'm looking at the exhaust valve here, the exhaust seat, and lo and behold, I do see what I believe to be a crack. Coming over to this one, my main concern is this crack. I hope you can see that in between the 2 valves on this side. Man, I really don't know what to do about that. From what I saw, new heads are $500 each. Yeah, I'll have to do some research and see how significant these cracks are. Well, I just got in contact with one of my friends who I met through the forums, the Type 4 forums on Facebook. Sent him a picture of the 2 cracks. Because it appears they are both toast. Maybe those cracks caused this engine to sit for the past 20 years. I don't know. Damn. Good morning. Today we are going to try polishing up this crankshaft a bit. To do that, we are going to spray some WD-40 on these journals, use a 2000 grit sandpaper, wrap the journal in the sandpaper, and then use a string to go back and forth and try to polish these up a bit.
I even thought maybe you can even do this.
Or just by that.
Need too much, just a little bit, because this looked like there was no scratches, no problems. But we want some WD-40.
Okay, so just a quick recap. We went through each one of the crankshaft journals, removed the connecting rods one by one and replaced those bearings. We've got a combination of new bearings and old bearings sitting on the crankshaft just as protection for now, so we don't get any debris in there. Cleaned up nicely. So now we're going to try to reheat the gears that go on the end of the crankshaft here, and the spacer that goes in between them, and finally the C-clip that we had trouble with. Not exactly sure how we're going to heat it up yet, probably on the vise here with a torch after some cleaning.
Somehow go. Let's see. The mark goes under here. Nope, it's not gonna go. Nope. It's missing. Oh, you still can do it.
Boom!
I was a little concerned.
Needs to counterclockwise a little bit. Yeah.
Yeah, there is room for the ring, right?
Yeah, there is.
Okay. Well, we're gonna have to trust it.
Okay.
Done.
There we have it. Finished crankshaft. Just missing one bearing here.
Put the old one for protection.
Okay, so we've got all new bearings that go on the crankshaft installed. We have new half shell bearings that go on each side of the crankcase installed. We've got a clean crankshaft, and we're going to give setting it a try into the crankcase.
Have to hold it by these.
Yes.
And then those go in. So, there we go. Now the bearings.
So we've got the crankshaft in. All the bearings are matching up with their dowels. Spins nice and easy. And also got new camshaft bearings in as well. And we're in the process of cleaning up the camshaft right now. Okay, we've got the heater running in the garage, so it's loud and it's a little bit to talk while inside there. It's been a little difficult filming the past day because there's just been a lot going on and a lot of stuff got cleared off the list, but some in order, some out of order. We're at a point now where we've got the crank and the cam installed, all new bearings. We're now going to apply Permatex aviation sealant to some components and gray gasket sealer ATV around others. If there's rubber involved, we're going to do Permatex aviation sealant. If it's just two metal to metal mating surfaces, we'll do silicone. So I'm going to set the camera up and hopefully film us closing the crankcase. All right, guys, it has been about 10 days since I recorded progress of us closing up this crankcase. I'm at a point now where, as of 30 minutes ago, all of the parts I ordered are in. We've got a new drill to replace the one that ended up in the oil pan a while ago. We've got used push rods, thanks to a friend that I met in the Type 4 forum on Facebook. I've got an upgraded oil pump, and possibly the most exciting of it all, brand new cylinder heads. Whoops. Nice. Now, I was trying my best sourcing these out, and there's not a lot of manufacturers for these heads now, and I couldn't find anyone that would take on the challenge of refurbishing these, so I went with the options that I found online, hoping that it was quality metal. And I waited a week more for these to come in, and what do I see when I look at the top of the box before I even open it? I don't know. I'm not going to go back now and return them or anything, but hoping for the best. Also received brand new push rod tubes, new oil filter. These are spark plug boots, fuel injector, O-rings, top and bottom, new valve covers, new valve cover springs, bunch of new pin screws, 4 new spark plugs. And then in here we have brand new pistons, rings, jugs, wrist pins, C-clips. I haven't even opened this up yet, so this is my first time looking at it. But those will be one of the next things I work on. I've got to take my measurement for the piston ring gap. What I have to do with those is place the top 2 rings inside each cylinder. So that's 2 rings per piston times 4. So that's 8 piston rings that I have to individually put into the cylinders and check their gap. And most likely they'll need to be filed down a bit to achieve the manufacturer's recommendation for the piston ring gap. So that will probably be the next thing I work on. So for now, I'm gonna do a little bit of cleanup on this bench and this bench just to keep organized and lay out all of my brand new stuff. Would you look at that? He cleans up well. Oh, it's always a mess. An organized mess. So now these pistons came in the cylinders already with the rings on them. And every single video I've seen, people rebuilding these engines, has them checking the ring gap. So I'm gonna go through the extra effort of popping these pistons out, taking the rings off, and just triple checking the gap on 2 rings per cylinder, so 8 total. Okay, let's dig into this thing, see what we find. They come oily and dirty from the supplier because they want to keep everything protected from rust. And there we go. And honestly, it's probably better off that way. Less liability on their end. And if you're building an engine, this is something that you should definitely check and clean beforehand. I'm waiting on a package that has a ring compressor and pliers for expanding the rings. I don't think I'll really need it to get these off. I was a little afraid of damaging it, so that was easy. That's the top, facing upward. Yeah, that goes on pretty easy. I don't know if I'll need that tool. And then this one, I think is good to go. Time to check these rings. So, best way to do that is keep this upright. This is the orientation that it's going to sit in the cylinder. I believe you just put it in. Easier said than done. Put it in. Like so. And then flush it down with this so it's even all the way around. Yeah, that's good. That gap right here is what I'll need to check. I'll take out my feeler gauges. I need to go back to the manual to see what it's supposed to be. Be right back. Okay, I've got the manual open. Hopefully you can read that. Here are the piston ring gaps for the upper compression ring, lower compression ring, oil scraper ring, all for 2000 cc engines, this bottom number in the table. So the first ring, the one I have in now, should be 14 to 22 thousandths of an inch. The next one is 12 to 22, and the scraper ring is 10 thou to 16 thou. So first one is supposed to be 14 to 22. Here's a 12. 12 fits barely. Fits nicely around 12. And the next number I have is 15. 15 should be in spec, and it is. Okay, good. Now we'll go to 22. 22 does not fit. Okay, good. No filing needed on that one. Okay, now the next one will sit in there like this. Okay, this next ring is supposed to be 12 to 22 thousandths. Start with a 12. 12 fits very easily. 22. 22 does definitely not fit. We are within spec again. Wow, these are good. Okay, now just to verify with the other 3 cylinders that those rings are gapped correctly. Here we go. All done with checking the ring gaps. No filing needed. Honestly, they look really good. They were on the lower end of the acceptable range, but all within spec, give or take a couple thou. Hello. We are back again. It's a new day. Ben and Romas are working on taking apart these new heads. We would like to disassemble the existing springs from the retaining clips and releasing the valves to check on the seat condition of the valves. We already pulled one off and it looked okay, but we want to at least check 1 or 2 more to assess if they've been lapped already as well. I did purchase some valve grinding compound and a lapping tool just in case. So far they look okay. We tried using the Amazon tool thinking that it might be a little easier than the old cylinder head removal because I thought the old cylinder head might be a little seized. However, that wasn't the case. This tool still sucks. So what we've done is we've built this contraption out of a socket adapter, a washer, and this inertia socket, they're called, right? Inertia socket, which fits into the plate of this press. We've taken the bit that comes with the valve spring compressor tool from Amazon and put it into the chuck of the drill press, and we're able to put the cylinder head on top of this, where the valve sits on top of the socket, and press down on the valve spring pretty easily. So we're gonna set it up and show you what we've done to check out one of the valves so far. Okay, let me just show how much easier this is than that stupid Amazon tool. So this is the condition of the valve as we pulled it off without doing any lapping work ourselves.
Yeah, the lapping compound has roughed the surface all through, so that means it's all good. Engine oil.
Just a little bit of oil on the valve before we put it back. Next thing we're going to try is lapping in these jugs to the new cylinder heads, and to do that we're just going to use valve grinding compound, put a little bit on the surface of the top of the jug, and twist it into the cylinder head to create a light seating, almost like a scoring where the head is going to sit, and should create a better seal since we're not using any head gaskets. Good morning, guys. It has been about 2 weeks since I've recorded any progress on the Type 4 engine that we're rebuilding. I had my knee surgery about 10 days ago, and I'm still recovering from that, and recovery will probably last, I don't know, another few weeks until I'm out here fully engaged on the rebuild again. We're rebuilding knees and engines over here. Right before the surgery, I had placed a jug on both of the 1 and 2 cylinders and a piston inside, and calculated my as-built deck height, as well as calculated what my shimming should be at the bottom of each cylinder to attain about 40 thousandths of an inch in deck height, which is the recommended standard from the Bentley manual and the members on the Type 4 forum on Facebook. So I went ahead and ordered some shims for that. And in order to calculate what my compression ratio will be, I needed the deck height calculation that I just mentioned, as well as the combustion chamber size for each cylinder. So calculating compression size of each of my chambers was something else that I did kind of off camera in my kitchen, but I'll show you how I did it. So I made this piece out of some plexiglass that we had lying around in the garage. It's not perfectly circle, but it fits perfectly into the combustion chamber of the cylinder head, and with a little bit of Vaseline around the edge here, it creates this perfect seal. And I actually did it in this one because I have the spark plug in. Basically, you take a syringe that has milliliters written on it. You calculate how many milliliters you put into there, as well as the piston here, because this dish in the piston is technically part of the combustion chamber, and calculate how many milliliters you put into each one. And metric system is a 1-to-1 conversion from milliliters to cubic centimeters. So long story short, I calculated that I have 70 cubic centimeters, 55 in the head and 15 in the piston dish. With a 70 cubic centimeter combustion chamber, a 94 millimeter bore, 71 millimeter stroke, and about a 40 thou deck height, I should be looking at about a 7.4 compression ratio, which isn't performance. It's probably not the optimal compression ratio. I think it's 0.1 better than factory. I think factory for this engine was about 7.3, and I know a lot of guys strive for at least 8 to 8.5 on these rebuilds. So I'm not entirely convinced that this is the setup I'll be going with yet. There are a couple tricks of the trade that can get you a higher compression ratio without decreasing your deck height. The closer you bring the jug to the deck of the crankcase, the closer the cylinder head will get to the piston. Thus, the smaller the clearance is from the top of the piston to the valve. I'm not really sure if these dishes, they seem pretty deep, but I don't know how much clearance we really have between the valves and the top of the piston. The pistons I actually took off of the old engine did hit the valves, but that's because the valve was seized. Not sure if you can see, but there's one example of a chip. So I'm taking this time to triple check my calculations, talk to some experts in the forums, and just make sure that everything I'm doing is satisfactory, watching other people build theirs and comparing the build methods. So I'm probably being a little too picky, but I'm not really able to do any physical labor in this time, so too much thinking. But hopefully once I'm confident in all these calculations and a game plan, next video should be a good amount of work and a good amount of progress made on this engine. I think the jugs can go on with the pistons, rings obviously. The cylinder heads are pretty soon after. We still have to get the distributor gear put into the crankcase and attached to that one gear, that brass gear on the crankshaft. I was able to get the upgraded oil pump installed. I don't know what happened to the footage there, so I apologize, but it wasn't that complicated. And yeah, I'm really looking forward to this thing continuing to grow and be one piece of shiny new engine. Big old long block. So as always, guys, thanks for watching. Please like, comment, and subscribe. Helps the algorithm prioritize my channel. And any comments, suggestions, advice from any of you experts out there, always appreciated. So thanks for watching. See you in the next one.